Hey guys, what's happening? Today we're going to do the lesson on limits as a video. So what is a limit? It is the height or value. When I'm talking value, I'm talking y value of a function that a function nears as the function approaches. Approaches is the magical word, a given location / x value. So what the heck does that mean? Well, it means if I'm looking at this guy right here, this function down here, example 1, I'm talking about what happens to my function as I approach C from both sides. All right, so as I approach C from the left side, that looks symbolically like approaching C from the left. And as I approach C from the right side, what height, what y value, so on the y-axis, what value am I getting near? And I don't really care what the actual value of f of c is. That doesn't matter to us, okay? We want to know what value we are, magic word, approaching. So it is very important that those two things converge upon the same value. And we don't really care what's happening right at C. It could be a hole, it could be a point, doesn't matter. It could be a hole with a value somewhere else. F of C doesn't matter. It's all about what are we approaching from the left and the right side. Alrighty? So here, for a limit to exist, the left and the right side of the given point, you have to be converging upon the same value. You have to approach the same height. So let's look at these examples. This example 2 here, limit of f of x as x approaches 2. So let's look at what's happening on the left side as we approach from the left. Approaching 2 from the left. By the way, this is supposed to be 2 here. So as I approach 2 from the left, it's approaching some hole, okay, that looks like it has a value of about 2. So I could say that the limit of f of x as x approaches 2 from the left side is about 2, probably 2. Let's check out what happens as we approach 2 from the right side. Following the function, go into 2. All right, so as we approach an x value of 2, that we're getting close to the same value that we got from the other side. So the limit of our function as x approaches 2 from the right side looks like it was approaching a value of 2 as well. Now I don't care that f of 2 was equal to, looks like f of 2 is -1. I don't care. Okay? All I care about is that the limit from the left, and the limit from the right are the same number. So here the limit does exist, and that limit is equal to 2. All right. Looking at example 3, I'm approaching -1 on g of x. I want to see if that sucker exists, and if it does, what is it? So the limit, let's look at from the left side of g of x as x approaches -1 from the left. All right, so approaching -1 from the left side, following the function, it's approaching this number. Yeah, it looks like as I approach -1, I get closer to a value of -1. Crazy. Oops, I don't know why I wrote that there. That's supposed to be a G, by the way. Alright, now let's look at what's going on from the right side, because we need the left and the right to be the same for the limit to exist. Unless they just asked you about the limit from one side. They do that. Alright. So from the right side, approaching -1 from the right side, approaching x value of -1 from the right side, looks like I'm getting close to a different value than before. This one looks like it's getting closer to a value of 1. And you should be able to see, hey man, this one's going to a different place than this one's going to. You should be able to see that. Those two numbers are different, so therefore, the limit does not exist. Kind of like Mean Girls, right? The limit does not exist. That's my Katie Heron impression. Okay, we can also look at limits in a table and see what's going on in the table here. So number 4, evaluate the limit of h of x as x approaches 1. So remember, from the left side and the right side, it's got to approach the same value. So we're looking from the left side. What's happening? From the lower values, I got 5.64. I got 5.64. Now, oh, it seems that I'm starting to get closer to 5.65. All right, let's see what's going on from the right side, from the higher values. 5.66, 5.651. So although the value here does not exist, it looks like both sides were getting really close to a value of 5.65, probably. Or at least that's what I intended it for it to be. So we would say our limit exists and it equals 5.65. Cool. Let's look at example 5, another table. All right, so the left side, the smaller values, getting closer to 3. I've got negative 100, negative 1,000. Oh, okay. So from the left side, we're getting bigger and bigger negative numbers. So the next one could be like negative, I don't know, 10,000? I don't know, something. It could be a super large, shoot, it could be negative infinity for all I know. Now let's look at what's going on from the right side. I got 100, I got 1,000. So, man, I could have like a positive 10,000. I could have like a positive infinity. But I hope you realize that the left side is getting more negative and the right side is getting more positive. So they're not converging upon one number. In fact, there's a very good chance that this could be some kind of 1, 2, 3. One of these guys here. So from the left side approaching negative something, and from the right side approaching positive something. Could be like a vertical asymptote where the limit does not exist. The limit, j of x as x approaches 3 does not exist. Because the limit from the left side, the limit from the right side were different. So what we should have learned in this video is what a limit is. All right, magic words approaching. What value are you approaching? And how it's different than just the value of a function. Okay, we don't always need the function to exist at that point, but we do need it to approach a value there. How to evaluate a limit from a graph in a table. Well, I hope I learned you that. And then lastly, when a limit does not exist, I hope that you also learned that. That is the end. Goodbye.